Hello, welcome to Free Math. In this video, let's have a look at a problem from INMO 2016, the fifth problem. So let's read the question. Let ABC be a triangle with centroid G. So let's draw a triangle with centroid G. Recall that a centroid is the intersection of the medians of a triangle. Okay. So ABC is a triangle with centroid G. Let the circumcircles of triangle AGB and AGC intersect the line BC in X and Y respectively. So the circumcircle passing through the points AGB intersect the line BC at X, right? And similarly, the circumcircle passing through the points AGC intersect BC at Y. Okay, so we have something like this, yeah, which are distinct from B and C, of course. Now we're going to have to prove that the point G also happens to be the centroid of the triangle AXY. So this triangle that you see over here, we're going to have to show that G also happens to be the centroid of that triangle AXY. So this is an interesting question. Let's see how the proof goes. So first what we can do is let D be the midpoint of BC. Okay. Now since G is a centroid, so the median AD will obviously pass through G, right? So D is the midpoint of BC. Now what we're going to do is we're going to use something called as power of point. Now if you're an Olympiad student, you should have a very good knowledge of power of point. It is frequently used in all of the geometry problems. So by power of point, let me tell you what power of point says. So D is a point which is lying outside these two circles, right? So D is a point which is lying outside these two circles. So power of point says dx times dB will be equal to dg times dA, okay, with respect to the blue circle, and also with respect to the green circle, it also says dy times dc is equal to dg times dA. So that is what the power of point says. So let me repeat it once again. So for the point D, with respect to this blue colored circle, we have dx times dB equals dg times dA. And with respect to the green circle and the point D, we have dg times dA equals dy times dc. So since this is a connecting bridge, therefore we can equate these two things, these two quantities. Dx times dB equals dy times dc, right? And since dB is equal to dc, because D is a midpoint, right? We already said that D is a midpoint. So therefore we can finally say that dx is equal to dy. So we can finally conclude that dx and dy, these two lengths are equal. So what does that mean? That basically means that D is a midpoint of xy. Yeah, D is a midpoint of xy. So that means AD happens to be a median of triangle xy, AXY, correct? So now can we say that G is the centroid of triangle AXY right now? Yes, we can, because G is a point on AD such that AG upon GD is 2:1 ratio. Why? Why can we say this? Because G is the centroid of the triangle ABC. That's why, correct? So therefore, finally, G is the centroid of triangle AXY, and hence proved. Beautiful question. So thank you for watching. If you have any doubts, please feel free to ask in the comments. Thank you.